Okay, about halfway done. So 3 more minutes to knock it out. Okay, excellent. So hopefully you all had a chance to complete the warm up. What you will see in Canvas now is that many of the deadlines have been updated to explicitly express that they are due on this coming Tuesday, September 1st. So when you log into Canvas, it should populate a schedule or a calendar for you on your home screen, which will show you upcoming due dates. And ultimately, this is not to cause you all any more stress. It's just to give you an opportunity to remain organized, as well as to see what you have and have not done. I want to appreciate and shout out Kiki for turning her camera on. I really appreciate that. You are consistent with it. So you are being a leader in that department. All right, yesterday we did take a quiz. I want to talk about that briefly. The quiz did not go horribly, and I know many of you might be discouraged by what your scores were because you're all such good students and historically you've done well in your classes. But the first quiz of a biology course is a little bit different just because there are so many terms that are new and you all are learning things at a rate that you may not be used to. The two other biology teachers and I had a discussion yesterday after school that lasted about an hour about how we can make the class a bit more conducive to what your learning styles are and what your learning needs are at this time. And so we have decided that we will probably do another test. Instead of just doing these shorter quizzes, we'll probably continue doing cumulative tests. And so what this means is that the quiz that we took yesterday ultimately will count for something, but it probably won't count in a way that will hurt you too much. So we're still thinking through exactly what that will look like. Maybe it'll just be extra credit. Maybe we will curve it so that everyone is, getting some sort of boost. But ultimately, we don't want it to hurt you all. And my goal in this first month or so of school is for you all to build the momentum that you need and build the confidence that you'll need to succeed in the class going forward. I don't want you to be discouraged by anything that happens too early on. Biology is not easy. I mean, I've taken several biology classes over my lifetime as a student, and I have had much more experience with these concepts than you all. So give yourself some time and give yourself some grace to better understand exactly what these concepts are talking about. And as long as you know that you're doing all that you can, and you can look yourself in the mirror at the end of the day and say that you've done what you were supposed to do, then you're in a good place, and you can't beat yourself up over that. Go ahead, change my attendance. I see Dante's here. Thank you for joining us, Dante. All right. So that being said, we do need to continue with some new concepts today. Unit 1 is pretty short, and hopefully you all had a chance to get down that table that I introduced, and I'll show that table on the slides shortly. But hopefully you had a chance to copy down that table or take a picture of it, this one right here. This is what's going to be your bang for your buck. Today we're talking about enzymes, which you can see down there at the bottom. Enzymes are an example of proteins. I believe that came up in your warm-up because there should have been a question about what is the building block for an enzyme. So that requires you to make some connections. But if you know that an enzyme is a protein, then you know that all proteins have the building blocks amino acids. So that should have been your answer for that question. But today we're going to expound on enzymes and explore them a bit more and introduce them conceptually. So hopefully you all are in a good place to start the lesson. I have someone volunteer to read our objective for the day.
Biologists will be able to explain how environmental factors can affect enzymes' functions. Essential question: what does it mean for enzymes to have an optimal environment?
Excellent, Castro. I love that. Thank you for speaking up. Thank you for articulating so well. Definitely want to encourage you all to be as participatory and as engaged as possible. So today we are talking about enzymes, which are a class or a type or an example of proteins. So as we think about note taking, and as you all hopefully are taking out your notes if you don't have them out already, we want to think about the fact that there are so many different ways to take efficient and effective notes. Efficient meaning that you don't want to spend too much time doing it. You want to be able to pull out information quickly. And effective meaning you want to be able to pull out the most useful information and the most relevant information. One of the best ways that I know to take notes is through these mind maps. And these mind maps allow you to create, I guess, diagrams or pictures of the information as you see it. So I just want to ask, if you looked at your notes as they currently stand, could you fill out this chart? Hopefully the answer is yes. As you see at the top of our diagram here, we really just need to list the 4 macromolecules, but you need to be able to list them in the right places based on the information that's given to you. So just out of curiosity, I'm not going to actually type into this or write into this, but what would go here? Which of the 4 macromolecules?
Proteins.
Proteins. And how did you know that?
Amino acid.
Excellent, because proteins are made up of amino acids. Good. Let's jump all the way over here to the right side. What should go here?
Nucleic acid.
Excellent. Nucleic acids. Good. And how did you know that?
Because I saw RNA.
Good. So we're taking time to recognize that there are clues, there are hints in other parts of this diagram. So I think that was Ayana. That's 100% correct. Nucleic acids should go here. So if you're a little bit confused and you're not sure where we're getting these words or what should fill out these circles and ovals, then that probably means that you still have more work to do. And you should go back and look at some of our previous lessons, or you should sign up and schedule an appointment with me on the side so that we can go over some stuff one-on-one. But we have to emphasize note-taking, and I know I've been harping on it a lot over the first 2 weeks of school, but because we are not in person right now, I have no way of knowing what your notes look like and if they are effective notes. So you all have to take responsibility and make sure that you're taking notes in the way that is going to be the most productive for you. It doesn't have to be my way. It doesn't have to be Miss Fields' way. It doesn't have to be Mr. Potts' way. It has to be whatever works best for you. And if that first quiz didn't go as well as you wanted it to, then that might mean you need to reevaluate your note-taking style. But I'm going to send a link to the chat. I think I've mentioned this before, but if not, that link right there is where you can sign up for an appointment with me if you want to have like some one-on-one time. Typically, I try to keep it to under 15 minutes because there might be other students who are trying to schedule on the same day. I've already had a couple of people take advantage of it in this class, and I appreciate that. So that time is open. I reserve that time for you all. If no one signs up, then I'm still technically available, but I prefer that you all try to schedule an appointment at least 24 hours in advance. What happened to my captions? Okay. All right, so jumping right into the lesson for the day. As I said, today we're talking about enzymes. Perhaps you've heard the word enzymes before we even started with biology. But an enzyme is a protein that speeds up chemical reactions. You're seeing RXN right there. RXN means reactions. I'll type that into the chat. Good morning, Olivia. Thank you for joining us. I see you've just joined, so I'll change my attendance.
Good morning.
So for those of you who, I think I mentioned this in a lesson at some point last week, but we try to make it easier for you all to take efficient and effective notes by highlighting the words that we want you to write down. So definitely on this slide, make sure that you have that enzymes are specific because they have a unique shape and that they are made of amino acids. Additionally, enzymes work with only one substrate or reactant. So substrate and reactant are synonyms. They essentially mean the same thing. And that substrate must fit into the active site for the reaction to take place. I appreciate Ayana and Kiki and Jalen for having their camera on because I can see that they're taking notes. Oh, hi, Angela. I see you just joined us.
Sorry, my Wi-Fi was acting up.
All good. I think this is the best attendance we've had so far. Okay, so if we look at that GIF, whatever you want to call it, down here at the bottom, this moving image, does anyone want to think about, or can anyone think about and share an analogy that comes to mind when you see that?
Pac-Man.
Okay, Pac-Man. Yeah, it does look like a Pac-Man figure.
A puzzle.
Okay, puzzle. That's a great way of thinking about it.
Pie chart.
Well, why do you say puzzle? Who was that? Let's see.
Because you gotta fit pieces in to make something.
Exactly, exactly. So with a puzzle, the shape of the piece matters. You can't just connect any two pieces. And additionally, typically puzzles have images on them as well that make them even more specific. So we can think about enzymes and their active sites and substrates as being different puzzle pieces that have to fit together in a specific way. Alicia, did you have something else?
I just said pie chart.
Okay, a pie chart. Yeah, it does look like we're taking out a piece of the pie chart and putting it back in. What about a lock and a key? Can someone say more about how this might be similar to a lock and a key?
A key needs to fit in a lock for
And go ahead. Okay, so that's 100% correct. So the keys that I use for my apartment, will that same key open the school door, or will that same key open your house door?
No.
No, no. So specific keys can only be used for specific doors, and that's because of the shape of the key. If you look closely at most keys, they have little divots in them. Looks like small bites almost that have been taken out of them, and that's what allows them to be specific. That's what allows certain keys to open certain doors. Same way, enzymes work the same way. Their shape only allows them to interact with specific substrates. And if I took my key that I used to get into my apartment and I bent it, that key is no longer going to function in the same way. Or if I chipped off a piece of the front, it won't function in the same way. And the same thing happens with enzymes, and we'll see that in a couple more slides. Okay. So again, the stuff in yellow is what we really emphasize and want you all to write down. It says enzymes are catalysts, meaning they speed up chemical reactions by lowering the activation energy. That's confusing potentially, but we'll see, I think, a better image on the next slide. But the activation energy is the energy that's needed to start the reaction. So just go ahead and get this down, and then I'll move to the next slide so you can just listen as I explain the concept. Okay, looks like note takers are done. Same information is on the next slide too, so if you didn't get it all. So I like this image because it really shows you what the activation energy is. So some of you have taken chemistry, I know already, or you at least have some background in chemistry.
I thought you picked chemistry in 11th grade.
Typically you do. Some people go out of order just because they might transfer in from another school district that does things differently. Anyway, so we've got reactants and products in this image. The reactants are the starting point. You always start with reactants. And your products are your finish line. You end with your products. Okay, so you can see down here on my x-axis, I've got time. So as time goes on, I'm moving from reactants to products. I start with reactants, and as time goes on, I move towards the products. But I can only move from reactants to products if I can climb the hill. Okay, so I need to climb the hill in order to start the reaction. If I can't get to the top of that hill, then my reaction never takes place, right? So we can almost picture this like an actual hill. And if I tried to roll a ball up a hill and I didn't use enough energy, then it would just roll right back down. So I need to be able to use enough energy to get to the top of that hill. And that way, the rest of the way, the ball will just roll itself down because of gravity. So the height of the hill, or the amount of energy that I need to use in order to get to the top of the hill, is called the activation energy. If I don't use enough energy, if I don't use the activation energy, then I'll never get to the top. But the cool thing about an enzyme is that it shortens the hill. So I don't have to use as much energy to get there. Enzymes lower the activation energy. They lower the hill. And so that makes it a lot easier to climb the hill, and we can do it faster and we can do it with less energy. Can someone unmute themselves and explain that back to me in their own words?
Enzymes lower the activation energy.
Good. And what is the activation energy?
The uh, the catalyst. I don't know.
Okay. See, I'm glad that comes up because that means that I need to try to do a better job of explaining it. So let's go back. Oops. So again, our goal is to start with reactants and change them in some way. They need to undergo some sort of chemical reaction. So I don't want to finish with the exact same thing that I'm starting with. I want to finish with something new, with products, after those products have undergone a chemical reaction. But in order for me to start that chemical reaction, I need to put in some energy. And the amount of energy that I need to put in is called the activation energy. So again, if I picture there being a ball at the bottom of this hill, those are my reactants. In order for me to get this ball all the way to the top of the hill, I need to use energy. I need to roll it up. And that amount of energy is called my activation energy. If I don't use enough energy, then I never get to the top of the hill and the ball just ends up rolling back down. So I end up with the exact same thing I started with. But if I do use enough energy and I can get to the top of the hill, then my chemical reaction starts. And then I'm going to start rolling towards something new. I end up with with some new products. The good thing about enzymes, which we can also, enzymes are catalysts. The good thing about them is that they decrease the amount of energy that you need to use. So instead of using 100% of my strength to roll the ball up this tall hill, with an enzyme, I only need to use 80% of my strength or 50% of my strength to get the ball up the hill. And again, as soon as we get to the top of this hill, my chemical reaction starts. And I can move towards the products. Okay. Good, 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 good. All right. There was supposed to be a GIF here. I'm not sure what it was. But these chemical reactions that I'm talking about are happening 24/7 inside of our bodies, in the bodies of everything else that's alive, and even in our atmosphere. Okay, climate change is the result ultimately of many chemical reactions. So chemical reactions take place all the time. The thing is, in our bodies and in the bodies of most other living things, those chemical reactions would be extremely slow because they would require a lot of energy. So enzymes do us a huge service. They help us out by lowering the amount of energy that we need to use to do these chemical reactions. So they make the chemical reactions happen much faster. Oh, I remember what that GIF is. So similarly to how, starting a fire with a flint and a stone, or you're just rubbing sticks together, would take a long time. If I were to just use gasoline and a match, then the reaction happens extremely quickly, right? So we can think about enzymes as that gasoline that's going to make the fire very big and happen very quickly. Okay. Oh, there it is. I thought it was supposed to be a GIF, but oh well. Okay, one of the other most important qualities of enzymes is that they are reusable. They're reusable because they don't change shape in the midst of a reaction. So when I put an enzyme into a reaction, the enzyme comes out the exact same way. It doesn't change shape during the reaction. And that's good because it means that I can use it again and again and again. That's what we mean by reusable. Okay. I also want to point out something. When you see the letters OSE, what should you be thinking about when you see those letters OSE?
At the end of the word,
Yes, ma'am.
sugar, some type of sugar.
Yes. Excellent. Good. So when I see, or when you see OSE, you should be thinking about sugar. But when you see ASE, you should be thinking about enzymes. Okay, so I was explaining to a student yesterday that, like I said at the beginning of class, sometimes you just need to give yourself grace because this is all new information and it's a lot of information at first. But the second unit, I think, will be a bit easier for you. So just keep your confidence up and understand that this takes time. And as you get exposed to these things and you start to pick up on patterns, it'll become second nature to you. And as you see these letters, OSE, you'll think sugar. As you see these letters, ASE, you'll think enzyme. And you won't even really have to work to make those connections. It'll just come to you. Okay, so I'm glad that we are already starting to establish those foundational connections, but it's going to take time to actually truly internalize them and understand them, and you won't have to work as hard to think about these things. Thanks for joining us, Joseph. Good. So today's definitely our best day of attendance ever. We only have one person absent. Okay. So I typed the ASE hint into the chat, but you'll notice here amylase ends in ASE. Amylase is your enzyme in this case. Then we also see maltose ends in OSE, so it's a sugar. Okay. Based on the diagram below and the same diagram that we saw on the last slide, starch must be which type of biological molecule? And you guys should remember this hopefully as an starch is an example. Exactly, it's a carbohydrate. Can you speak to, I'm not sure who that was, can you speak to why, it was Alicia. Can you speak to why you think or how you knew it was a carbohydrate?
Well, I just looked at my notes.
Okay, good. And that's great. You know, I think that that's exactly how you should be going about things. So we should remember, or you have your notes available to you, that carbohydrates, well, I'm sorry, starch is an example of a carbohydrate. But also another way that we can tell from the diagram is that as amylase, which is the enzyme, as the enzyme breaks down starch, it turns it into a sugar. So that can only happen if starch is also a sugar. Okay, so I can only create sugar by breaking down sugar, aka carbohydrates. All right. So I think we just have a few more slides. So enzymes can be used to digest large molecules into their monomers. And they can also be used to synthesize new molecules. So the word digest, what do we think digest means in this context?
Bring it in. Eat it.
What'd you say?
Oh.
Bring it in.
Okay, yeah, we can see that they're, so in this case, I know that the diagram is a bit confusing. These two shapes, the yellow hexagon and the orange hexagon, they're connected already.
I have a question.
Yes, ma'am.
So is it like breaking it down and then combining the remaining particles together, or what?
Exactly. Yes. So the word digest in this context means to break it down. Okay. So if we look at this image, thank you, Ayana, for saying that. We see that the orange and the yellow shape are connected. They are one shape, and the enzyme separates them to create. I guess that's supposed to be red. It's not supposed to be orange, but it separates them to create two distinct substances. Then in the other case, the synthesis, the enzyme is taking two distinct substances and it's combining them to create one substance. So enzymes are capable of doing both. They can digest and they can synthesize. They can break down and they can build. The only thing that I'd add to this, and I don't want to confuse you all, but this would not be the same enzyme. This would be two different enzymes doing this. Okay, so enzymes have specific jobs. The ones that break things down, that's what they do. and they do it well. That's all they do. They just break things down. The ones that synthesize things or that build things, that's what they do, and they do that job well. And you'll start to see that that's another general theme in biology, is that substances have specific roles that they focus on, and they do that role well. And when they're asked to do something else, it doesn't typically end up in a good place. Same thing, just like in our bodies, for those of you interested in medicine, we have all these different types of cells, but they each have a specific job to play. The cells that are in your eye are not the same cells that are in your tongue that allow you to taste things. That just wouldn't work out well. Okay, so these things all have very specific jobs. Okay. All right, so in this exercise, let's think about polymers and monomers, polymers and their monomers. So we want to think about what these enzymes are used for. It says, number one, protease. So there's that ASE ending again. Protease breaks down proteins into what? If I break down a protein, what should I be left with? Again, we want to be thinking about polymers and monomers. So if protein is the polymer, then if I break it down into its monomer, then what should I be left with?
Amino acid.
Excellent. Yeah, amino acid. So again, thinking about monomers and polymers. If I take two monomers and I put them together, then I create the polymer. But if I break a polymer down, then I'm creating the monomer. Okay, so we got to be thinking in these relationships. And that's why that table is so important. When I'm thinking proteins, I've got to also think amino acids. When I think amino acids, I've got to also be thinking protein. All right, so let's try number two. Amylase, there's your ASE ending again. Amylase breaks down carbohydrates into what? What should a carbohydrate be broken down into? What is a carbohydrate's monomer?
Glucose.
Glucose. Yeah. So if I break down carbs, then I'm going to be left with glucose. Deoxyribonuclease breaks down nucleic acids into what? What's the monomer of a nucleic acid?
Nucleoside?
A nucleotide, yes.
Oh, I'm so sorry.
No, you're fine. I think that that's basically correct. They're almost the same thing. Nucleotide. Okay. And then number four, lipase breaks down lipids into
Fatty acid.
yes, glycerol and 3 fatty acid tails. So again, over time, this stuff will become second nature to you as long as you are exposing yourself to these concepts. So in your mind, you've got to start making these connections. When I think protein, I've got to think amino acid. When I think nucleic acid, I've got to think nucleotide. When I think lipid, I've got to think glycerol and 3 fatty acid tails. These are my connections that I start to make. When I think examples of proteins, I got to think enzyme. When I think enzyme, I've got to think catalyst. Break things down, build things up. I start to make those connections. Okay. And then again, all of the enzymes end in ASE, protease, amylase, deoxyribonuclease, lipase. It's very common. Not all enzymes end in ASE, but for the purposes of this class, most of the enzymes you will see and hear about will end in ASE. All right, so take some time to sketch this diagram into your notes. If you are not writing with pen and paper, then you might want to try to take a screenshot of this or a picture of this. This is a very important image.
I know this sounds like a stupid question, but do you know how to take screenshots on a Windows 10 computer?
Windows 10. I don't, but I can look it up. Shout out the internet. How to take screenshots on Windows 10. Do you have a button that says print screen or it says PRT SCN?
Yes.
Okay. So if you press that button, then it'll copy your entire screen. And then you can paste it into a document.
I'm not sure it worked.
It won't like show a notification that anything happened, but it should still be copied and you'll just be able to paste it into a document of some sort.
Okay, all I have to do is look at it in the files, I guess.
No, not in your file. So you'd have to open up a Google Doc or a Word doc or Google Slides or something like that. And then you can paste it.
Sorry for the trouble.
No problem. Apparently, you can also press the Windows key plus the print screen button, and it'll save your entire screen as an image in a pictures folder. So multiple ways to do it. You've taught me something new today. Jalen says his computer is slow. You are not alone in that, my friend. You are not alone. Tech issues are just rampant these days.
I'll be right back. I have to help my brother with his work.
Does anyone need more time here? Kiki says no. I don't hear anyone. I don't see any messages.
No.
Thank you. All right. Thank you, Angel. All right. So let's see. How many more slides do we have? Okay, this is the last one. So really the last important concept of enzymes is related to all the other concepts, and that's that the shape matters. The shape is the most important thing. So if I change the shape, I change the function. When an enzyme changes shape, it's called being denatured. Typically, temperature and pH are responsible for changes in the shape of an enzyme. And every enzyme has an optimum range. Some enzymes like it a bit hotter, some enzymes like it a bit colder. But outside of their optimum range, they will begin to change shape. Same thing with pH. Some enzymes like an acidic environment. They like to be at a pH of about 4. Some enzymes like to be in a neutral environment. They like the 7 pH. Some like a basic environment. Maybe they like to be in an environment of a pH about 11. But if I move too far away from that optimal range, then the enzyme will change shape and it will no longer work. I actually wish that I had included another picture here. Okay, let me just add one more slide. Okay, so here are 2 common enzymes that we have inside of our bodies, pepsin and trypsin. Like I said, not all enzymes end in ASE, but most of them do, many of them do. But pepsin is a stomach enzyme. And as many of you probably know already, our stomachs are pretty acidic environments because they have to be able to break down the food. So pepsin is comfortable being in an acidic environment. It likes a low pH. This graph shows that pepsin really prefers to be at a pH of about 2, which is very low. That's very acidic. And what this graph also shows is that as I move away from 2 in either direction, the enzyme just doesn't work as well. Do you see how the graph gets lower? That represents that the enzyme isn't working. The rate of the reaction is slowing down, so the enzyme is not working as well. At a certain point, it gets so low that it just doesn't work at all. What point is that? Can someone tell me at what pH would pepsin no longer work?
0 and that other number. Never mind.
Yeah, 0 and 4. Yeah. So one thing that I want to point out that Ayana just did really well is that we recognize that there are 2 points at which that happens. Okay, so the range is above 0 but below 4. And then for trypsin, which is an enzyme that is in our intestines, it likes a more basic, almost neutral pH. So anything that's more acidic than 6, a pH of about 6, and anything that's more basic than a pH of about 10 is not going to work for trypsin. It prefers to be, I guess that would be 8 or 8.5. I'm not sure exactly what this graph is trying to say, but that's the concept of optimal or optimum environment. Same thing for temperature. And the asynchronous work for today, I think, will really explain this to you because it's a video by the Amoeba sisters. And as you watch the video, there are, I think, 7 questions that you'll need to answer, and they're in order. So once you get to a certain point in the video, you'll be able to answer the first question, then you'll be able to answer the second one, and so on and so forth. So that's what we have. 18 minutes left in class. Not 8, yeah, 18 minutes left in class. I'll put myself on mute. That's what you should be working on. If you have questions, please let me know. But the Amoeba sisters, it can be found in day 5, unit 1, day 5, just below the warm-up that you all did.
Mr. Rudd,
Yes.
the video's not working for me. Like, it's not loading.
Okay, let's see.
I refreshed it many times.
Okay, I'm sending the link to the chat. I'm also going to update the assignment so that the link is provided there for you as well. Thank you for bringing that to my attention. Did it work, Ayana?
Yes, it worked.
Okay. Okay, people, it is 11:35, so I will let you go there. I hope that everyone has a fun and productive and relaxing and rejuvenating weekend. Please do remember that our due date for all of our Unit 1 assignments is approaching on Tuesday, September 1st. So please make sure that you use your time wisely to both recuperate but also be productive this weekend. If at any time you need anything, you know how to reach me: email, phone number, remind, chat, whatever comes to mind. You can even send me a message via Canvas. Have a good weekend.
I have a question.
Yes, Ayana.
If we have a problem on something over the weekend, like on a work, are you going to reach back the next week, like on Monday, or are you going to actually?
I will be responsive to emails and text messages on the weekends, as long as it's not, at like 11:30 p.m.
Okay, thank you. Have a good day.
You too.